Why edge detection is so crucial in image processing? Well, it's because edges are the boundaries between different regions in an image, a set of connected pixels that mark a transition in color or intensity. Understanding these boundaries allows us to separate and recognize individual objects and features in data. Edge detection is a fascinating process, and it generally involves three main steps: noise smoothing, edge enhancement, and edge localization. Firstly, noise smoothing. It's a good practice to start with this step because it helps reduce noise in the image. Noise can be thought of as random variations in brightness or color information, and smoothing helps make the image cleaner and edges easier to detect. Next, we have the edge enhancement step. This is where we identify the points that may be a part of an edge. It's crucial to understand that the transition in the gray level associated with a point has to be significantly stronger than the background at that point. We use a threshold to determine whether a value is significant or not. If the point's two-dimensional first-order derivative is greater than a specified threshold, we label it as an edge point. Now, gradient operators come into play. These operators provide us with two key pieces of information: the magnitude, which gives the quantity of the increase, or sometimes referred to as the gradient 2, and the direction, which is perpendicular to the direction of the edge. Instead of computing the partial derivatives at every pixel location in the image, an approximation is calculated using a 2-get-2 or 3-get-3 neighborhood centered about a point. Finally, the last step in the process is edge localization. This is where we select the true edge members and compose them into an edge. This selection is done using a technique known as thresholding. If the threshold is too high, very few edges are detected, leading to many gaps. On the other hand, if the threshold is too low, too many edges are detected, leading to many extra edges. So to summarize, edge detection is a crucial aspect of image processing that involves identifying the boundaries between different regions in an image. This process involves three key steps, starting with noise smoothing to clean up the image, followed by edge enhancement to identify potential edge points, and finally edge localization to select the true edge points and compose them into edges. It's a fascinating field that combines elements of mathematics and computer science to help us better understand and interpret the visual world around us. Remember, the art of edge detection is all about finding the right balance. Too much noise smoothing might lead to missing important features, while too little might make edges hard to detect. Similarly, the right threshold is crucial in edge enhancement and localization. Too high and you might miss out on important edges. Too low and you might detect too many. It's all about finding the right balance to accurately represent the image. And with that thought, we wrap up our discussion on the importance and process of edge detection in image processing. From identifying the boundaries in an image to understanding how to balance the various steps in the process. Edge detection is indeed a fascinating and critical aspect of image processing.